Hi guys, I hope all is well. Okay, you're looking at STTN121. This chapter 15, the hypothesis testing for for two population. Yeah, for two population. Let me just share my screen. This an interesting chapter. I hope you checked out my video for one population, the hypothesis testing for one population. Okay, just do this. All right. Now it's okay. I think it's good now. All right. The hypothesis testing for two population. This is interesting. Um, Remember, whenever you're given a question or you're given a scenario, try to check like the keywords. Are you given the mean, the x, the n, the standard deviation, the variance, and so on? So, okay, now this with the hypothesis testing for two population, let's check here. Let me check something. So we are going to perform the hypothesis testing for the difference between the two population means, and also we're going to perform the hypothesis testing for the difference between the two population proportions. So meaning the hypothesis testing for two populations, we're going to perform the hypothesis testing for the difference between two things. The first one is for population means when we have the large sample, and the other one when we have the small samples under the one for the population means. But then now, with the one for the population proportions, we're only dealing with the large samples. You'll see the formulas. The formulas, they are not the same. But with this one, the formulas here, they are not the same. There is a formula for the large samples, and there is a formula for the small samples. Then as for the population proportions, you're only using the same formula. I'm going to show you the formula. This is just a recap for the hypothesis testing for one population. For the one population. Okay. You all remember the steps. Hypothesis testing for one population and for the two population. The steps are the same thing. We are still using the same steps from the hypothesis testing for one population. Step one, it's when you formulate the hypothesis. It's when you are formulating the null and alternative hypothesis from this one. And then step two, it's when you are specifying the significance level. Remember, you'll be given the significance level as the alpha, maybe 0,1, 0,05, 0,01. And also you write down the formula, the appropriate formula for the test statistic. Now on step 3, it's when you're going to substitute using that formula that you wrote on step 2. Then you calculate the test statistic on step 3. Then step 4, it's when you state your decision rule, you calculate the p-value. For each, if the p-value is less than alpha, or the p-value is less than the significance level, then you reject the null hypothesis. Yeah, something like that. And then now, since now on step number 4, you stated your decision rule and you calculated your p-value. Step number 5 is when now you draw conclusions. Or now, since you rejected the null hypothesis, now there is sufficient evidence or insufficient evidence. You make your conclusion, or you make a decision, or you interpret. That is step number 5. Okay, let's see. First one. This is the hypothesis testing for two population means. Remember, on this chapter, we're comparing two population means. So on the scenario, you will be given sample mean 1, sample mean 2, standard deviation 1, standard deviation 2, sample 1, sample 2, which is N1, N2. So now we have the condition that if we are dealing with the large samples here, we are dealing with the large samples N1, is greater or equal to 30. Let's say, for example, N1, you get 35, and then N2, maybe it's 40. Then the formula that we are going to use, we're going to use the one for the Z, which is sample mean 1 minus sample mean 2, which this is the variance 1 plus variance 2 divided by N1 and 2. Then you get the test statistic. Remember, this is the formula for the test statistic, where the Z is normally distributed with a mean of 0 and a standard deviation of 1. So yeah, like this. This is the formula that we are going to use when you are dealing with the large samples under the population mean. This is the one that you are going to use. Then from the thing, the hypothesis for one population, I think I talked about how do you see that the alternative you're going to use less than, greater than, the two-sided. Yeah. And you all know that with the null hypothesis, you're going to use the equal sign. But then now, with this one, with the two population, you remember that with the one population, if you were given a value of the population mean, you used to say that HO, where population mean is equal to, maybe that value 20 is equal to 20. But then now, and then under HA or H1, you say that the population or the null alternative hypothesis is greater than maybe that 20, or is less than 20, or is not equal to, which is two-sided. But with this one, we are going to compare two population means. It's like when we do one example. Okay, this is an example here. Example. So for the test, I think you guys will be given something like this. You need to check and differentiate, or how do you see that this is population, this is the hypothesis for two populations. How do you see that? It's very important for you to differentiate. Now, when you look at this one here, you need to check. I'm going to highlight the keywords so that you can all see the reason why they said this is two populations. I'm going to highlight the keywords so that you can all see. And the formula that we are going to use. Remember, we said that if the N1 is greater or equal to 30 and N2 greater or equal to 30, we're going to use the method of the Z. Don't forget to follow the steps. Step 1, step 2, step 3, step 4, step 5. Yeah. Now let's check. I use this one. Yeah. Now, a study is done to estimate the difference in salaries of teachers in what? In private, and okay, it's fine. That's what I'm going to in private and government school. So it means that here we have the salaries of teachers in private and also the government school. So now when we look at the question, they say schools in a specific education community. Now, a random sample of 100 teachers at private. This is a random. So this is N1. This one, it's N1. I hope we can all see that. N1 for the private. Okay, let's say. And then at private school showed an annual mean, meaning the sample mean here. It's what? It's 105 here. So meaning this one, it's what? This is standard deviation 1. No, the mean. So the mean, not the standard deviation. So this is the mean, which is x bar 1. X bar 1. And then they say that with the standard deviation of what? The standard deviation of, so I mean the standard deviation here in this case, it's 15,200. Okay, let me, this one. The standard deviation is equal to what? 15,200. So, meaning this one, it's S2. Remember, we're dealing with the two, we're comparing, this is S1, yes, S1, because now it means that the private is the population 1, where we're going to have N1, X bar 1, S1. Now we're going to move to the one for the government. I'm going to use this one. So this one, you can see they correspond, even the colors. A random sample of 200 teachers at a government school. So this will be N2. So this is how you see that this is N1, this is N2. You see, this will be N2. Okay. At government school realized a mean annual salary of 88,000. So the mean with using this highlighted, this one. So this one will be x bar 2. X bar what? 2 here. Because you remember doing the hypothesis testing for two populations. And then with the standard deviation of 13,500. This one will be what? S2 under the population 2. Now, remember, this is the information. Don't forget, you check the part of the alternative. Remember, how do you see? Remember, if they mention that it's greater than, it means that the population mean 1 will be greater than population mean 2. If they say less than, population mean 1 will be less than population mean 2. But if they don't say anything about greater than, less than, and what, we take it as the two-sided. Meaning population mean 1 is not equal to population mean 2. And when you take it as two-sided, the probability will change, remember. So here in this case, let's check the statement. Test the hypothesis that the mean salary of teachers at private school is population 1 is higher than the keyword higher than, which is greater than. So it means that under the H1 or HA, you're going to have something like this one is greater than this one here. Because of what? Because of the statement here. Because of the statement. So population mean 1 is greater than population mean 2. Okay, given the significance level is 5%, which is 0.005. So yeah. So that's how you identify the population 1 details or the values and also population 2 values. So now let's check. Let's see. You see, step 1. This is step 1. You formulate population mean 1 is equal to population mean 2. Population mean 1 is greater than population mean 2 because of the higher than. If it was less than, we're gonna put this less than. But if they didn't mention anything, they just say maybe sufficient evidence or what, we're gonna put something like this. Yeah, this is the symbol that they use, which is this is the symbol for the two-sided. Symbol for two-sided. Yeah, that isn't why they used greater than. They used greater than. So now, step 2 is when you specify the level of significance, which is its alpha, 0.05. Now remember we said that under the hypothesis testing for the population mean, we need to check if N1 is greater or equal to 30 and N2 is greater or equal to 30, we're going to use the method of the Z, which is this one, x bar 1 minus x bar 2, variance 1 plus variance 2, N1, N2. Already we're given those values. I just showed with those values, x1, x bar 1, N1, and S1. We just substitute. But on step 2, you don't substitute anything. You just write down the formula here of the test statistic. But when you go to step 3, it's when now you substitute. When you substitute and calculate what? The Z value, which in this case, they got the Z value of 9.47. So it means now, since they got 9.47, they got 9.47. This probability here is not there on the table. So what do you do? If the probability is not there on the table, they take it as 1. But because you remember that under the language of probability, we said that if they mention greater than, at least, exceed, more than, we're going to say 1 minus the probability. So it means that 1 minus our probability, which is 1 here. That reason why we got the answer of 0. That's the reason why here it's 0. Therefore, that was step number 4. Therefore, now you're going to compare the probability with the significance level. So the p-value less than alpha. And alpha is 0.05. So the p-value is 0. So we're going to now 0 less than 0.05. The bigger one is the alpha, this one. Therefore, we reject the hypothesis under step number 4. Understand? Step number 5 is when you draw conclusions or make decision. Since we said that we reject the hypothesis, it means that we agree with the statement that the mean salary of teachers at private school is higher than. Because you see, it's higher than that of teachers at government school. Because we reject the hypothesis. But let me check something here. Okay, a random sample. Okay, test the hypothesis that the mean salary at, okay, the minute we reject, it means that we agree with the statement that it is higher than that of the teachers at. But if we say we do not reject, it means that the statement will be talking about a different thing. So that's how you answer the question that are based on. If it's 7 marks, you see it's free 7 marks. Free 7 months. Okay, let's check the other one. This one, let's check. Okay, transport company in Helsinki. Okay, Finland wishes to know if the mean travel time to work differs between, check this one. Okay, commuters traveling by bus, that's the population 1, or by train, population 2. Okay, a survey was conducted among the bus and also the train. Okay, the test what, but when you check here, already they've given you the information that now this is alpha 0,1. But remember, when you formulate, check if they mention greater than, more than, less than, so something like that. But when you check, test the hypothesis that travel time for trained commuters is shorter than, which is less than. So it means that H1, HA, population mean 1 is less than population mean 2. Yeah, like that. So you see, we are given the information for population 1 and population 2. That's the information. So it's going to be easy for us to calculate. That's you see, the reason why they use less than here is because of this, shorter than. Then you do it like that from the previous question. Step number 3, use the formula, and then you get the probability. And then you compare the probability with that one. Since you reject, it means you're going to agree with the statement of that one of where they say that the train commuters is shorter than travel time for commuters traveling by bus, which is this one. Since you rejected, then you get to a free 7 marks. If it's 7 marks, yeah. Now we're going to talk about the one for the difference between the two populations when we are dealing with the small samples. Remember that one, the n, it was greater or equal to 30. You see, when you look at this one, n is greater or equal to 30, and 1, and 2 greater or equal to 30. Now, we're going to do the one when n1 or n2 is less than 30. Let's check. The formula that we're going to use is the T formula. The T. Remember, you need to check N1, check N2. Are they greater than or equal to 30? If they are less than 30, both of them, you're going to use the value of the T. You see, x bar 1 minus x bar 2, 1 over N1 plus 1 over N2. Where this SP, we are going to use the SP is equal to S squared P. You do it like this here, and then you get your S squared P. Then you substitute, then you get the T. But don't forget, this part is for the degrees of freedom. This one, n1 plus n2 minus 2. So let's look at the question. Okay, here they say that for two random sample size of n1, which is 11, look at this one. N1 is equal to 11, n2 is equal to 14. You see, 14. So it means that n1 is less than 30 and n2 is less than 30. So we're going to use the method of T, where x bar 1 is 68, x bar 2 60. This one is straightforward. S1 is 7.8, S2 8.4. Okay, already we are given the hypothesis here, and also this is two-sided. So when it's two-sided, you're going to choose 2 multiplied by the probability and so on. But this is T, remember. Use alpha, the level of significance is 0,01. So it means that for step 1, you saw it was clear for step 1. Step 2, you specify the level of significance. Step 2, and you also write the formula of the test statistic. This is the one. You see the reason why they said this they got 23 as the decrease of freedom is because remember N1, 11 plus 14 minus 2, you'll get 23. Now, step 3 is when you are calculating the test statistic. You substitute the values that you are given, but they started by calculating the S squared P. But when you see on the formula, it's SP, not S squared P. So after getting the S squared P, you're going to do a square root so that we can get SP. So the SP will be 8,145. Then they put it here. Then the test statistic, they got 2.438. Now you're going to use that method, the one of the P2 minus P1, the T2, T1. I think I've explained it on, not sure if you guys were writing class test 1 and class test 2. Yeah, I've explained it on how to see that this is T2, this is T1, this is P2, this is P1. Under STTN121. Then now you use this. There's a why. It's, remember, it's two-sided. So the 2 has to be there. You see. But because this value is positive, it's T greater than 2.438. And we know that when it's positive and greater than, we're going to use 1 minus. So it means that it's going to be 2 minus 2 into, you substitute your values. 2 minus 2, because it is like this. You can put 2 here. 2 multiplied by 2 is 2. 2 multiplied by this part is going to be this whole part minus 2. So that's the reason why it was 2 minus 2 into this whole thing. But it's all the same thing as 2 into 1 minus that probability value that you've got on your table. Then you will get this 0.023. Now, in the 0.023, you're going to go and check the critical value. Because now you remember, no, not the critical value. Since you're going to compare the 0.023 with the alpha, which is 0.01. So you see 0.023 and 0.01. The bigger one is this one, 0.02. Therefore, the p-value is greater than the level of significance. Therefore, we do not reject. That's the reason why they said we cannot conclude that the two population means they differ from each other, because we failed to reject the hypothesis at 1% level of significance. So yeah. Now, the last one is this one. The difference between the two population proportion. This one you always deal with the large samples. We don't have a population proportion where we are dealing with the small samples. Always it's large samples. N1 and N2, they will always be greater than 30, greater or equal to 30. The formula that we are going to use is P cap 1 minus P cap 2. But you remember that this P cap here, we said that it is going to be what? X divided by N. But since it's P cap 1, not it's P cap 1 is equal to X1 divided by N1, then the P cap 2, you're going to use what? X2 divided by N2. So you're going to be X2 divided by N2. N2 like this. N2. So yeah, something like this. Then you get this. This is P cap 2. Now, to get the whole P cap, the one with that doesn't have the value or a number, to get this P cap, we know that it's X1 plus X2 divided by N1. These are the formulas I'm talking about. You see, where P cap 1 is equal to X1 divided by N1. P cap 2, X2 divided by N2. The whole P cap, it's when you add X1 plus X2 divided by N1 plus N2, and you call it. The steps are still the same thing. Step 1, step 2, step 3, step 4, step 5. You formulate, you specify, you get, write down the value of the test statistic. Then step 3, you calculate the test statistic. Step 4, you compare the p-value with the level of significance. Step 5, you make a decision or draw conclusions. It's the same thing, but in this case, we're going to use the population proportions. So with this one, population proportion 1 is equal to population proportion 2. Even this side is very important for you to check the statement as whether maybe they mention greater than, less than. If they don't mention anything as whether greater than, exceed, more than, you're going to use this, which is the two-sided, the two-tailed. Let's look at the question, and how do you see that the question is based on the population, the hypothesis for population proportion. You see on this one, in a survey of 175 customers, 60 of them, they say what? They indicate that they will buy corn bix breakfast. You see, this one, okay? That's number one. If it is available in shops. While 40 here out of 150. Okay, let me just erase this. Okay, just 40 out of 150 customers say that they will prefer flake pigs. So it means that we have the population of the corn pigs, also have the population for flake pigs. Okay, test the hypothesis that the corn pigs, the hypothesis that the corn pigs is more popular. The corn pigs is more popular than the flake pigs. If alpha is equal to 0.1. So the reason why they say it's more, which is greater than. This one will be N1, and this one will be X1. And because that's the population of the corn pigs as population 1. Here, the 40 will be X2, because this is the population for the flake pigs. This one will be N2 here. Then you go to the step 1, you see it's greater than because of this. More is more popular than. So this one is greater than this one. You specify the level of significance. You write down the formula, the one that I've just explained. Then you know how to get the P cap 1 and P cap 2. X1 divided by N1. You got this. You do the same with the P cap 2. Then after you get this here, then now you write it down like this. then you get the test statistic. After the test statistic, we're going to get the p-value. Remember, if it's greater than 1 minus the probability, then you get the p-value. Now you're going to compare the p-value with the alpha. The p-value, I think, was 0.0694, then the alpha 0.1. So obviously the p-value 0.0694 and 0.1. So the bigger one is 0.1. Therefore, it's less than. So therefore, we do what? We reject the null hypothesis. Since we reject the null hypothesis, now we can now conclude. So they conclude that at a 10% significance level, there is proof that the population proportion of people on the yeah, then step number 5, you make a decision or a draw conclusion. So since they say we reject, it means that we are agreeing with the statement that the corn beaks is higher than those who prefer the flag beaks, which is more popular than the flag beaks. That will be your conclusion. So that's how you answer the questions that are based on the hypothesis testing for two population. One, you need to check the value of n1 and n2. Are they greater than or equal to 30? Then after you check the part where it's greater than, less than, or two-sided under the alternative hypothesis. Then after then you just do the calculations and then you get the answer. Then you formulate and then you also get the p-value. After the p-value, then you make a conclusion or you make a decision. So this is just the summary that if it's n1 and n2 they're large, you use this one. If n1 and n2 they're small, you use the formula with the SP, the one with the T. Then if n1 and n2 they are large, but under the population proportions where you will be given x1, n1, x2, n2. With this one, you won't be given mean, standard deviation, mean 1, mean 2, standard deviation 1, standard deviation 2. So yeah. So this is interesting. So that's how you answer the question that are based on the hypothesis testing for two populations. I think now it's done. Yeah. So yeah, please don't forget to like and subscribe so you can see more videos of STTN121.